Hey everyone, continuing for our conics, we'll be looking at the third graph, the ellipse, alright? And it's actually an oval. I hate to really say it, but it is, okay? And it has a very similar general equation to our circles, where we have x minus h whole thing square over a square plus y minus k whole thing square over b square, and strictly equals to 1. Another thing is, a cannot be b, because if that's the case, then, well, you can get the equation of a circle by multiplying a square or b square by both sides and have a radius of a or b. Now, and if you remember the shape of an oval, there's no radius at all because there's no constant quote-unquote radius, so that's why it's an ellipse instead of a circle. So once again, if we see the familiar letters h and k, but we're now with a and b. So again, hk is the center of the ellipse, and a and b, well, we'll talk about it when I sketch an example, of which we have x minus 1 whole thing square over 4 plus y minus, let's say, 2 square, let's leave it as that, equals to 1. Alright, so over here we know that, well, a equals to 2, b equals to 1, and hk is simply the center, which is 1, 2. Okay, so let's say this is 1, and then this is 2. Alright, let's say the center is at this point here. So what is this value of of a and b? Very simple. Alright, so if you look at a, is under x, and what we know about x is the horizontal axis. What it simply means is that from the center, the rightmost point, the right or leftmost point would differ this center by at least 2. That means from here to here would be 2, and this point here would be the leftmost point of the ellipse. Similarly, from here to the rightmost point would also be 2, and that will be the rightmost point of the ellipse. On the same idea, we have the uppermost and the lowermost point. But instead of looking at a now, because now the y coordinate when we talk about vertical movement, we're looking at the value of b, which is 1. As such, from here to the bottommost point is by 1 unit. From here to the uppermost point is by 1 unit. And that is the idea of having the values a and b. Alright, another thing is, depending on the value of a and b, you have either the major axis or the minor axis, where the major axis is the length of the quote-unquote axis that is the longer. So between a and b, we know that a in this case is 2, b in this case is 1. The length of the major axis is 2, which means that, well, if you see the word major axis, you know it's basically the longest distance from either the uppermost or the leftmost point to the center. Really depends on the context of the question. In this case, the major axis is 2 and the affects the x value, so it's the left and rightmost points, whereas the minor axis is the smallest one, which is b equals to 1, and it makes the uppermost and lowermost point. I will talk about this later on when I sketch the graph, but let me get rid of these arrows. Okay, so let's just sketch the ellipse. So we know that, well, it has the quote-unquote horizontal width, aka the major axis is greater than the minor axis. So we have this shape, alright? Once again, applying the same idea, the leftmost point is 2 away from the center, so we have the center at 1, 2, don't forget to label your center. We then have minus 1, 2, over here we have 3, 2, then upwards is by 1, so we have 1, 3, below is 1, 1, right? So this is how you should kind of plan your ellipse, right? Find out the uppermost, lowermost, leftmost, and rightmost points, and then figure out whether they cut the axis or not, or whether they just nice touches the axis. Alright, so this is our ellipse at x minus 1 square over 4 plus y minus 2 square equals to 1. Again, finding the y-intersection, just let x equals to 0, and then take the square root, which means you add plus minus, because you have y minus 2 whole thing square, and then put the coordinates in. So talking about the major axis, this is what I mean. So this would be the length of the major axis from here to here. So I'm going to write capital M as the major axis and small m as the minor axis. We have the major axis, which length 2, which is equals to a. Minor axis is at length 1 because b is less than a and b equals to 1. Looking at another example, where we now, instead of having a bigger than b, we now have b bigger than a. Alright, so let's say we have the graph now x plus 1 square over 4 plus y plus 3 square over 9 equals to 1. Alright, of course I can kind of change things out and let it be 2, which means that you have to divide by 2 to get 1. Alright, so here is strictly 1, but I don't want to waste time on that. Again, we have a equals to 2, b equals to 3 now, because now it's 3 squared. Then we have center at minus 1 minus 3. Alright, don't forget it is x minus h, y minus k. So we have x minus minus 1, y minus minus 3. Alright, so let's note down the center. Let this be minus 1, and well, let me just not have that far from negative for our y. So this is minus 3. Employing the same technique, alright, let's jot down the uppermost, leftmost, rightmost, and bottommost point. So we know that the uppermost point would differ by the center by 3 units because it's now uppermost, which is b, because it's affecting y. So so we have minus 1, minus 3. So the uppermost point will be at minus 1, 0. So it means that you'll just nice touch the x-axis. Alright, so the x-axis is kind of a tangent to the ellipse. Then the bottommost point will occur at minus 1, minus 6. So it's somewhere around here. Alright, I'm gonna draw the points a bit just to illustrate it, then I'll take away the points. Then our leftmost will be minus 1, minus 2, so it will be minus 3, minus 3. Our rightmost would then be 1 minus 3, right? Minus 1 plus 2, so it's minus 3. So your graph would just nice touch the x-axis and intersect the y-axis at 2 points, because our rightmost point is far away from the y-axis. Alright, so I'm gonna sketch the graph right now. Okay, just nice touching the y-axis. Okay, it's gonna look quite like a circle because wow. Okay, let me just change things up a little bit. Actually, I might need to do it more proportionate. Okay, didn't really think this through. Okay, let's say this is minus 3. Our center is here. Okay, now this will be a lot better. Oh wow, this is way too long. It's going out of the screen. Okay, I think something like this would work. Yep, something like this will work. Alright, so you notice that the uppermost, the major axis is now at the value at y, b equals to 3, because b is now greater than our a. So that is our major axis now, right? So this will be the major axis, length of the major axis. This will be the length of our minor axis. Right, so major axis equals to 3 and minor axis equals to 2. Alright, so it really depends on whether a is bigger than b or b is bigger than a. But whatever it is, take the biggest value, that will be the major axis. The smaller value will be the minor axis. Alright, so you don't have to label the other rightmost, uppermost, leftmost, or bottommost points unless they intersect the x-axis or the y-axis. Alright. Again, label your y-intercept. So we let x equal to 0, and then you solve here and somewhere around here exactly. Alright. So otherwise this would be the graph of our second ellipse, x plus 1 square over 4 plus y plus 3 whole thing square over 9 equals to 1. Alright. So that will be how you sketch an ellipse, and it's good to start off with, figure out the points first, or very simply use your GC. Alright, if you guys want to do it the easier way. Alright, so there we have it, ellipse.